Alright, so picking off on where we left off last lesson, where we learned about what a function was, we're going to learn about the type of notation that we use when we're dealing with functions. So we're not going to be doing anything really that you haven't done before today, but when you're dealing with functions, there's a special kind of notation we use to represent the different inputs and outputs and how we work with them. So first off, when we have a function, most of the time we give it a special name. So that name is usually going to be some letter. Most of the time that letter that we call it is going to be f. So we're going to call the function f. And once we've given a name to that function, we then put in brackets afterwards the independent variable. So this is read as f of x. So f being the name of the function and x being the independent variable. So as a couple of reminders here, we should only use this notation for functions. So it's just a regular relation. We use a standard y equals. And again, f is the name of the function and x is our independent variable. Okay, so if you want to look at a typical example of a common type of function, here's a quadratic right here. Back in grade 9, you have just simply said this is y equals 2x squared plus 4x minus 7. Okay, but now that we know it's a function, we're going to give it a special name. Again, f, and what we put here in brackets is the independent variable. So this is just really a name for the function. This does not mean f times x, or it's not like you're dividing by x here to solve for f. There's nothing like that. This is strictly the notation that we use to indicate this is a function of the independent variable is x. Okay, so what this means is that the input, the independent variable, is x. So what we can do is we can replace that input with absolutely anything. And again, we've done that before, right? We've subbed x values inside equations before to find the y values that go with it. So we can do that with absolutely anything we want. So for example, let's say given this function up here, I want to find f at 5. This is really just saying, this notation is telling me that x is equal to 5. So find what the value of the function, i.e. what the value of y is. So what this is saying is everywhere you see an x inside the equation, you replace it with 5. So in this case, we'll have 2 times 5 squared plus 4 times 5 minus 7. And then we just simply evaluate it the way we would have done like as if we were in grade 10. So you can see we work out the math here. Following BEDMAS, we get 2 times 25 plus 20 minus 7, which simplifies into 63. Okay, so when x equals 5, y is equal to 63. Okay, so again, it seems like I'm belaboring this point a lot, but just to go over that notation, saying that when f at 5 is equal to 63 is just a new notation for saying that when x equals 5, y equals 63. Okay, or of saying that the point 5, 63 is a point that's on this function or on this graph. Okay, so again, all stuff we've done before, just a different notation for doing it. Okay, so let's take it a little bit further. We're going to try the exact same thing, except now we're going to replace our input, our x, with different other values. So here we're going to find f of 6a. So again, what this means, I'm just taking my independent variable, my x, and I'm replacing it with 6a. So everywhere in the equation where I see an x, I'm replacing it with 6a. This is going to be 6a all squared plus 4 times 6a minus 7. And all that's left here is to try and simplify this further. Okay, I'll let you give that a try on your own, but just before you do that, I'll set up the next one the exact same way. So it says determine f of m minus 1. So again, I'm replacing my input, my x, with m minus 1. So I get 2 times m minus 1 all squared plus 4 times m minus 1 minus 7. Okay, so what you should do from this point, again, is try and simplify them as best you can. So I'm going to give you a minute to try and do those on your own. So give them a try, see if you can work through the algebra, and push play and you're ready to go through it together. Okay, so you can take a look at the answers here. So for the first one on the left here, f at 6a, so to simplify this, the first thing I want to do following my order of operations means I have to evaluate the exponent first. So 6a all squared is really just 6a times 6a, so it's 36a squared. Okay, and then I simplify down here by doing 4 times 6a. And then multiplying this through, I get 72a squared. There's no other like terms to collect, so I wind up with 72a squared plus 24a minus 7. The second one's a little bit tricky, mainly because here you have a binomial that's squared to deal with. So going back to grade 10 here, how do you expand binomial squared? Remember that when a binomial is squared, it's really just multiplied by itself. So m minus 1 squared is the same thing as m minus 1 times m minus 1. And you probably saw many different ways of expanding and simplifying this last year, but probably you worked with arrays a lot in grade 10. So it's going to be the same thing as m minus 1 times m minus 1 So remember, you set up a 2 by 2 array with m minus 1 and m minus 1 on the outside. You fill in each box of the array with multiplication. So you wind up with m squared minus 1m minus 1m plus 1, which simplifies into m squared minus 2m plus 1. Okay, from here on in, it's just a matter of using distributive property to expand and simplify, and then collecting your like terms. You wind up with, in the end, 2m squared minus 9. Okay, so again, a little bit of practice in algebra here, but again, all we're doing here, this notation is telling us to replace the independent variable, in this case the x, with something different, and then simplify as much as we possibly can. Okay, so I'm going to give you a bunch of different functions, and we're going to find two things for each one. So in each case, we're going to determine what f of negative 2 is. Okay, so a reminder that that's telling us that we're replacing x with negative 2. Okay, and we're trying to figure out what the value of the function, or what the y value is. So when x equals negative 2, y is what? Okay, and the second thing it's going to ask us to do is to find x if f of x equals negative 5. So we haven't seen a question asked quite like this before, but what it's telling us is that the whole value of the function, i.e. the y value, is equal to 5. And it's asking us to find the x value that makes this happen. Okay, so again, this is two different ways of asking questions compared to what you saw back in grade 9 and grade 10, but it's all things that you've done before. In each case, it's giving you one of the two variables, you have to find the other one. Okay, so let's do part I. So here we have a function, and the function is going to be a table of values. So f of negative 2, you're looking for when x equal to negative 2, which happens right here. Okay, and when x equals to negative 2, y is 7. So f of negative 2 is equal to 7. Okay, now for part 2 here, for this, we're looking for when y equals 5. So we look on our function, where is y equal to 5? So the function is equal to 5 here, and the x value is 7. So in this particular case, x is going to be equal to 7. Okay. So with that in mind, I'd like you to try to take the same approach to looking at B, as well as C and D. So give those a try. Again, answer both of these questions. What is f of negative 2, and the x value of the function is equal to 5. When you've done all three, push play and we'll go through them together. Alright, so running through these together. For part B here, so f of negative 2 means on the graph you look for x equal to negative 2. So that's going to happen here. So when x is negative 2, you look up on the graph, and you see that the y value there, so the value of the function is going to be equal to 3. So when x equals negative 2, y is 3, so f of negative 2 equals 3. For part 2, look for the function, or i.e. the y value is equal to 5. So when the function is equal to 5, you look out to the graph, and you're at this point right here. Okay, and then it's not an exact value, but you can look down to see what the x value is going to be. It's somewhere between negative 1.5 and negative 2.0. I'm going to estimate that point to be at about negative 1.7. Okay, so for part C, looking at the mapping diagram, when x is equal to negative 2, okay, remember with a mapping diagram you have your independent variable on the left, your dependent variable on the right. So you look for an x equal to negative 2, and following the arrow it tells you that at that point y is equal to 5. So f of negative 2 is equal to 5. Looking for the part 2, you're looking for where the y value is equal to 5, so the function is equal to 5. And you'll see there's actually two different arrows going to it. So there's two possible answers here. So when y equals 5, it could be caused by x being equal to negative 3, or x being equal to negative 2. You have to put down all the possible answers. So in this case, to get full marks, you have to put in x equals negative 3 or x equals negative 2. Both of them would be required. Last but not least, in part D, same idea, but now we're given the function as ordered pairs. So when x equals negative 2, you get a y value of 1, which answers part 1. And for part 2, you see that when y equals 5, it actually happens twice. So you have two possible x values that create a y value of 5, both 1 and 3. Okay, so let's just work a little bit more with function notation right here. So here we're going to be given a linear function, so f of x equals negative 3x plus 7. So a typical line like you would have seen back in grade 9. And with all that, I want to determine all these 5 different expressions. So f of 5, f at 5 minus f of 2, f at 5 minus 2, f at 5, then subtract 2, and then 2 times f at 4 plus 17. I'm going to let you try this on your own first. I want to see how well you apply the definition of function notation here, and see what you can come up with. Some of these expressions have subtle differences between them. I want to see if you can figure them out on your own first. So when you've tried them all, push play, and we'll go through them together. Alright, so let's take the time to go through our answers here. So for the first one, It's a bit straightforward by now. So it's asked for f of 5, which means that you're replacing the x value with 5. So everywhere you see an x in the original function, you're replacing it with 5. So you get negative 3 times 5 plus 7, which gives you negative 8. Okay, moving over to the right here, it asks for f of 5 minus f of 2. So again, putting this into words, it wants the y value when x equals 5, and then it wants you to subtract the y value when x equals 2. So thankfully you already found the y value when x equals 5, so f of 5 was equal to negative 8, so you can sub that in right here. For f of 2, I would suggest working that out on the side. So f of 2 is negative 3 times 2 plus 7, which gives you 1. So you sub that in for f of 2, so you get negative 8 minus 1, which gives you negative 9. Okay, moving down on the left on the next row. So now you have f of 5 minus 2. Now, what's different here is that the 5 minus 2 is all inside the function there. So you can simplify inside that bracket first, which now tells me is going to be f of 3. And so once it's simplified down to this, it's just simply a matter of subbing 3 into the function for x. Then you wind up getting negative 2. Okay, to take it even further over to the right, now you have f at 5, and then you subtract 2. So the difference between those notations seems subtle, but it's a very big difference. So this one simplifies to f of 3, the one on the left. The one on the right here stays at f at 5, and then once you've evaluated that, then you subtract 2. So f at 5 is negative 8. We found that over here in the first one. So we put that in, and then we subtract 2. So negative 8 minus 2 gives you negative 10. Okay, and last but certainly not least, now we have 2 times f at 4 plus 17. And it's a situation like this where you tend to see a lot of confusion where people start thinking, oh, I've got f, and it looks like this might be multiplication by 4. It's not. Every time you see an f, you can assume that everything that's after it in brackets is part of the input of that function. So this needs to be taken separately from the other. So f of 4 really, again, means the y value when x equals to 4. So we evaluate that. Negative 3 times 4 plus 7 gives you negative 5. Then we put that back into the equation, replacing f at 4, and then it's something we can work with. So once we've got that, we then multiply it by 2, and then add 17 to get a final value of 7. Okay, so working with function notation is going to be something you need to get used to. We're going to use a lot this unit. It's going to show up in almost every single unit in this course, and big time in grade 12 as well. So it's really important that you take the time to get used to working with it so it becomes almost second nature to you. Okay, so we're going to look at a few more examples here. So in each of these cases it says solve for x if f of x equals 4. So we've got 4 different functions here, and what it's telling you is that the function itself, so i.e. the y value, is equal to 4. Okay, and you need to solve for x. So let's set up the first one together here. So we're told that f of x equals 4. So the left side of the equation here is equal to 6. Oh, sorry. Pardon me, it's equal to 4. My mistake. So we have 4 equals 2 bracket x plus 5 all squared minus 6. Okay, and what it wants us to do here is solve for the x value that makes this work. Okay, so there's a couple ways of going about this one. I'm going to first solve it using algebra, and I'm going to show you what we call an input-output approach that you may have seen before in a previous course that might work quite well here. But first, let's do it algebraically. So I'm trying to isolate for x here. I have an equation. So the nice thing about here, this is only one x in the equation, so I should be able to isolate for it using algebra. So to get the x by itself, you can see that I have a lot of obstacles here. I have 5 added to it, there's a multiplication by 2, there's an exponent of 2, and we're subtracting 6. So I got to make sure I'm reversing the steps to build this equation to solve for it. So the first thing I'm going to do here is actually add 6 to both sides. Okay, I'm not going to divide by 2 because I have to divide this 6 by 2. I can't take the square root because this 2 and this negative 6 aren't put to that square to that power of 2, so you can't take the square root. So you got to take it piece by piece. So I'm going to add 6 to both sides of the equation here. So 4 plus 6 gives me 10. So I'm left with 2 times bracket x plus 5 all squared. Okay, still can't take the square root of both sides because, again, this 2 is not squared. So now I'm going to divide both sides of the equation by 2. So I get 5, which is equal to x plus 5 all squared. Okay, now I can take the square root of both sides of the equation. So I'm left over here with plus or minus root 5, 2 possible answers here, which is equal to x plus 5. And then my last step here, I'm going to subtract 5 from both sides of the equation. So I'm left with x being equal to plus or minus root 5 minus 5. Okay, So I'm running out of time here, so I'm going to talk more about the solution in part 2 of the video and then take a different approach. So we'll see you over there.